Hello, this is Dr. Lori. Here we are again. We are looking at our fictitious data on disease and the risk factor exposure. And here's our completed 2x2 table that we arranged in our last video. So once you have arranged the data in this 2x2 table and you have all of the information laid out the way that it's easy to look at in a systematic way, the next thing that we do is we like to calculate some kind of critical value. And the thing that I like to point out is that if you are an epidemiologist, you generally calculate something called an odds ratio. And if you are a biostatistician, a lot of times they will calculate something called a chi-square test of independence. Now, both of these are looking at the same data just in a little bit different sort of a way. And it's not a hard and fast rule. I know epidemiologists know how to use chi-square test of independence, and biostatisticians calculate odds ratios all the time. But historically, there's been a little bit of a divide in that particular respect. So here we have our data. We have 19 out of 20 cases were exposed, and 3 out of 40 controls were exposed. And what we'd like to do is, in this first section, we'd like to calculate something called an odds ratio. Now, odds has a little bit of an explanation. It's a little harder to understand than risk. Risk would be where I calculate 19 out of 20, or 95%. Odds, on the other hand, I'm looking at the two groups compared to each other. So really what we're doing is we're calculating the odds of exposure among cases, and then we're calculating the odds of exposure among our controls. Now here's our exposure. So the odds of exposure in our cases is 19 to 1. And our odds of exposure in controls is 3 to 37. One good way of thinking about this thing about odds is to think about the relationship of, say, boys to girls in a second grade classroom. So let's say you have 15 boys and 11 girls. The odds of being a boy is 15 to 11. So odds is a different kind of measure than, say, the prevalence or the proportion overall. So let's go ahead and write out the equation here. So here's my odds. Let me get a different color. My odds for cases is equal to my number exposed to my number not exposed, which is equal to 19 over 1, which is equal to 19. So my odds for my cases is equal to 19. Now let's calculate my odds for controls. Again, it's equal to the number exposed divided by the number not exposed, which is equal to 3 over 37, which, if you grab your calculator, it's equal to 0.081, and that repeats 081, 081, 081 forever and ever and ever. So here we have our odds for our cases and our odds for our controls. And the answers, if I was in math class, I would be supposed to put a little box around them. So there's my answer, so that it stands out for the teacher to grade. And what we want to do is, when we calculate something called an odds ratio, is we want to compare those. We want to compare them specifically to each other. Because if the odds for the cases was the same as the odds for the controls, then we would say, probably nothing going on. But if the odds for the cases is higher or lower, significantly higher or significantly lower, noticeably higher or noticeably lower than the odds for the controls, then that's where we say, maybe there is some kind of relationship between that risk factor and that disease. And so our odds ratio is equal to, go back to purple, the odds for cases divided by the odds, if I draw slower maybe it's better, for controls, which is equal to 19 divided by 0.081. Now, if I don't round anything at all in all of those calculations, you can check my work. I got 234.3. So that is essentially what we're doing when we are calculating something called an odds ratio. So for this particular relationship that we set the 2x2 table up for, we want to know, is there some kind of relationship between that risk factor and that disease? If I know something about whether someone is a case, will that help me know whether they were exposed? In other words, is there a relationship then between being exposed and being a case? And this number out here, with practice, you will realize that that is a very large number. And the answer to that question is, yeah, it seems pretty likely that there's some relationship there between the exposure to that particular thing and then later on developing that disease. So that concludes my demonstration of how to calculate the odds ratio. In our next video, we'll be looking at the chi-square test of independence.